Following on from the previous video, we were trying to find out the derivative of the inverse tan of x, and we got to this stage here. Hang on. So we would start with this here. We're trying to find out the derivative of this. So we would tan equally to both sides. So from here, that would take us to here. And then when you're here, you've got to visualize it as you're tanning a bubble here. So implicitly differentiate both sides. So that would then you've got to use a chain rule here, because remember, y is a function of x. So you've got to differentiate this and then later on times dy by dx. So looking at this here, at the moment you're tanning a bubble here. So remember, we did several videos on this here. Whenever you differentiate tan of x, it will give you this here. So looking at this here, at the moment you've got tan a bubble here. So differentiate this, so that would then give you 1 over cos squared of y, and then you've got to times, because y is a function of x here, you've got to times dy by dx here. So differentiate this using the chain rule, it will then give you this. Okay, it will then give you this, and then differentiate this, that will then give you 1. So now you can imagine that as this thing multiplying to the top here. You want to isolate this, get this y prime on its own. So you would times cos squared y to both sides. That would then give you y prime. So our dy by dx here equals this. This is really our final answer here. Dy by dx equals this thing here. But the thing is, the answer here is in terms of y. We don't want the answer in terms of y. Well, y here equals this thing here. We could put this into here. We could put it into here. That will then give us the answer. Y prime equals cos squared and then inverse tan of x here. You see, this answer here is really messy, and we don't really fully understand what's going on here. So here's a cunning way. So here's a cunning way. We started out with this here. My point is that if you put this into this y here, just blindly putting in there, it will look ugly, and we don't really understand it. So here's a cunning way of doing it. You start with this, tan equally to both sides. That will then take you to this, and then blah blah blah. We got to y prime equals this. Here's a cunning part. Looking at this, so we started here. Looking at this here, looking at this stage here. Translate this into a right angle triangle. So looking at this here. Hang on. Looking at this here. Remember, tan y equals x. Okay, tan y equals x. Remember, tan y equals x. Looking at that stage here. Translate what's being said here into a right angle triangle. So remember from trigonometry, tan, let's say y is the angle here, tan y equals, remember tan is the opposite over the adjacent. So looking at this here, translate this into a right angle triangle. So looking at this here, tan y is opposite. Let's create this length here to be x. Now this is just a trick. It's a cunning trick. Looking at this here, translate this into a right angle triangle. So if we make this length is x and this length here as 1, then this thing here is true, and then this is also true. So now looking at this here, what is cos of y? Well, looking at this triangle here, cos of y will be this. Cos of y will be 1 over, now what's this length here? Well, this length here, by using Pythagoras, this length here will be root x, remember, x squared plus 1 squared, and then square root it. So this length here is given by this. So tan of y was blah 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 here, but then we started with here, we translated to here, and then from here, well, earlier we started with tan, but then we translated the whole situation into cos of y. Well, cos of y will be 1 over this thing here. over root x squared plus 1. Remember, this is just a cunning trick. So we started out with tan of y, but then we translated to cos of y. Now looking at our answer here, y prime equals cos squared of y. Well, if you think about it, cos of y equals this thing here. So cos squared would be this thing squared. Looking at this thing squared would be this. Hang on, would be so cos. Hang on, cos of y equals this thing at the moment. So cos squared will be this thing times by itself. So it will be plus 1, and then times by itself. X squared plus 1. So top times top, that equals 1. And then bottom times bottom, that will give you x squared plus 1. So look, cos of y equals this thing here. Then cos squared of y will be this thing here. So y prime is, remember, is this thing here. Alright, let me just repeat it. So hang on. So we started out with this. You see what I mean later. Hang on. So remember, we started out with this. Tan both sides, that will then give you this. And then blah blah blah. Using implicit differentiation, we would get to we would get to this stage here. Okay, we would get to this stage here. But then by looking at this, we translated this situation into this right angle triangle here. Okay, but remember, tan of y, hang on, tan of y is this thing here. Tan of y is this thing here. But then we translated this tan of y into the cos of y. Remember, cos of y is this thing here, which is this thing here. Okay, and then we can square both sides, because at the moment our answer is y prime equals cos squared of y. But then we can translate cos squared of y by this thing here. Well, will then give you y prime equals this thing here. So the cunning part is really this bit here, translating this into this right angle triangle, and then turning the tan of y into the cos of y. Somehow translate this into the cos of y. And then once you've got, because our answer was y prime equals cos of y, but we don't really understand what this thing means. So we translated this thing into cos of y, and then from here we can easily put this into this thing. Well, I hope you understand it. Okay.